The nth term of an arithmetic sequence is determined by the formula t sub n is equal to t sub 1 plus the quantity of n minus 1 times d, where t sub n is the nth term, t sub 1 is the first term, n is the position of the unknown term, and d is the common difference. We are going to find the general term of an arithmetic sequence. In the first example, we are given the first four terms, 3, 8, 13, 18. So in order to find the general term, we are going to use the formula for the nth term, and that is t sub n is equal to t sub 1 plus n minus 1 times d. As you can see, we need to identify the values of the first term and the common difference. Our first term, or t sub 1 here, is equal to 3, while the common difference is equal to 8 minus 3 is 5. After that, we are going to substitute the values. So t sub n is equal to, instead of writing t sub 1, we are going to write 3 plus the quantity of n minus 1 times, instead of writing d, we are going to write 5. Then we are going to perform the operations by following GEMDAS. So between multiplication and addition, we are going to multiply first. So that is why we need to copy 3. N times 5 is positive 5n. Negative 1 times 5 is negative 5. After that, we need to combine like terms. So since 5n is the only term that has a variable, 5n will be copied. Then, combine 3 and negative 5. So 3 plus negative 5 is negative 2. Remember, in adding integers having unlike signs, you need to subtract their absolute values and copy the sign of the integer with a greater absolute value. So now we can say that the general term of the sequence 3, 8, 13, 18, and so on is t sub n equals 5n minus 2. Let us now proceed to the second example. In the second example, you are given the first term and the common difference. So the process is the same. We are going to use the formula for the general term, and that is t sub n equals t sub 1 plus the quantity of n minus 1 times d. Substitute the given values. So t sub n is equal to, instead of writing t sub 1, we are going to write 100 plus the quantity of n minus 1 times negative 10. I don't know if you have noticed that I always enclose the common difference in parentheses. Because if I am not going to enclose the common difference in a parentheses, the operation here is subtraction. Look at this, n minus 1 then minus 10. So that is why we are going to enclose the common difference in parentheses. It is important, again, to enclose the common difference, especially if it is negative, in a parentheses. Because if not, the operation will change from multiplication to subtraction. Let us now simplify the equation. So t sub n is equal to, so in simplifying equations, we need to follow again GEMDAS. So between addition and multiplication, we are going to perform first multiplication. That is why we are going to copy 100. then multiply n and negative 10, n times negative 10 is negative 10n. Negative 1 times negative 10 is positive 10. After this, we are going to combine like terms. So since negative 10n is alone, because there are no other terms that have n as an integer, we are going to copy negative 10n and then combine 100 and positive 10. So 100 plus positive 10 is equal to positive 110. Therefore, we can say that the general term of the arithmetic sequence with 100 as first term and negative as the common difference is t sub n equals negative 10n plus 110.
The general term of an arithmetic sequence defines a sequence. Sometimes, a term is denoted by a instead of t. I will now give you examples on how to find the nth term of an arithmetic sequence. Are you excited to know if your answer in activity 1 is correct? Watch the next video.